Plastic did not become one of our most widely used materials on accident. Plastic is cheap, it's durable, flexible, it's very, very useful.
Plastic has a function, and until you replace that function, it's going to stick around.
And stick around, it does. Of the 9 billion tons of plastic that humanity has ever produced, 7 billion tons has become plastic waste. In the United States, only about 5% of plastic is recycled every year. The rest of it ends up in landfills or the environment. From Arizona State University, welcome to Lab Coat Optional, the show where advanced research meets everyday curiosity. I'm your host, Pete Zrioka, and today's guest is a friend of mine. Charlie Rolsky is an ASU trained scientist who has a better understanding of how much plastic sticks around than most of us. His work has taken him from coast to coast, studying microplastic pollution in marine life, to wastewater systems, and the human body. He's the executive director of the Shaw Institute in Maine, exploring the effects of plastic pollution on the environment, as well as potential links between plastic accumulation in our bodies and chronic diseases. We talk trade-offs, greenwashing, the state of Maine, New England's best state, and why progress in the fight against plastic pollution is rarely as simple as just swapping out one material for another. Charlie, welcome to the show.
Look at us.
Look at us.
Look at us.
Look at us.
Yeah, we were from being scolded for talking too much to now getting paid to talk too
even
much.
more.
Yeah. This is really special.
I appreciate you coming all the way from the great state of Maine to our Arizona studio in February. I know there's not a lot to get you out of Maine in February, right?
Oh, it's lovely. It's really lovely. Like the heaps of snow and all of the great restaurants closing. It's just the place to be.
Yeah. The black ice.
Oh, it's just tremendous.
Yeah.
But it preserves people. Like our friends are in their 80s and they're totally fine and working full time. It's a preservative.
Well, okay. Yeah.
Goals. And then out here, the sun is just like...
Yeah, it tries to kill you.
Yeah, exactly.
Yeah.
It's a good mix.
You are known for your background in microplastics research. When did you originally become interested in this field of study?
I was working with killer whales and they only ate Chinook salmon. And I kept finding these in their fecal samples that didn't feel like bone from a fish. And then it ended up being plastic. And then I would wonder, why is it that a 30-foot animal would have something in it that's 5 millimeters in size? And then that took me to Arizona State. And I started asking that question with my advisor, and an idea was born.
Well, that's kind of an upsetting thing to find plastic in this big, beautiful animal. Right?
Yeah, it didn't make any sense to me. I knew about bioaccumulation, but that's not something you visibly see if it's something like mercury or DDT.
So when you say bioaccumulation, you mean like the buildup of something within a body?
Yeah, I mean, you have a couple ambient pieces in the water, right? A couple pieces of plastic. A shrimp eats 2 pieces, and then something eats 20 shrimp. So you're multiplying it, by 10. So now that thing goes from 2 to 20, and then whatever eats that thing, and then it goes from 20 to 100. And then by the time it reaches us, we're talking several hundred pieces.
Not good for us. Bioaccumulation of plastic. I'm also going to assume it's not good for whales.
Yeah.
So what were you finding that was detrimental to the whales because of all this plastic in their food source?
One of the difficult parts of this research is it's hard to prove something came from one thing when there's a range of pollutants around us, right? Light pollution, noise pollution, chemical pollution. There's a lot of different things happening at once, but we do know that there's a range of threats associated with them.
Okay.
So they can have things stick to the surface that are bad for us. The internal chemistry, we've all heard of like PVC piping. VC stands for vinyl chloride, which is a carcinogen. So there's things inside that are bad, things outside that are bad. And if it's a small enough animal, just the physical particle can be a problem.
Right.
But one of the most difficult things in this field is it's hard to prove one negative effect came from one pollutant.
Okay.
When there's a lot of pollutants.
Microplastics, there's a lot of them, right?
Yes.
And when I say a lot of them, they kind of permeate the environment. You were specifically, and are still specifically focused on marine ecosystems, but they're not just there. They're kind of everywhere. Do I have that right?
Yeah. We focus mostly on environmental health. That was my interest. I like people, but I don't want to work on people. Not that kind of doctor.
Sure.
But as being a nonprofit in this day and age, things have changed a little bit for us.
Oh.
But anyways, so we don't lead as much as we sort of listen to the demand of the research world. And the demand is now human health.
Okay.
You're finding it in oysters.
Yeah.
Are you finding it in us? Can you
Right.
find it in us? Can we send you samples? So we're now listening to that demand, and that's the new course of the field, is looking at how these things affect humans, which is, it's terrifying, but it's also kind of nice because we have that connection to the environment, where usually humans look at the environment like separate of us, but we all, like, you eat haddock,
Yeah.
seals eat haddock,
Yeah.
I eat haddock.
Uh-huh.
So it's good that we're kind of seeing that connection now.
So you said that's terrifying. Are there aspects of this work that like keep you up at night?
Not really.
No?
No. And I kind of owe that to being in a lab where they really liked plastic while it's being used, but they really hated it in the environment.
Okay.
So I learned a lot more about what could affect us negatively and the overall perception of plastic pollution, where I do see it being sensationalized a bit, and I do see the really scary headlines. And I've kind of learned to sort of separate the two from each other. We don't want them in our body, but what is the actual effect of them being there? If there's a plastic bottle floating in the ocean, yeah, maybe it can turn into a microplastic. Maybe it just accumulates barnacles and floats. And maybe it doesn't do anything.
Right.
So it's important to sort of discern between those two, make sure that we're actually finding a negative impact.
Is there anything about this kind of work that gives you hope then? Because you said it's terrifying, but are there hopeful aspects to what you're studying right now?
There are, and that, I think that again comes from my postdoc, where people understood that plastic has a function. And until you replace that function with something that's kind of in the same price range and it's durable, all the good things that makes plastic useful to us, until you replace that function, it's going to stick around. But there's more companies that are focusing on innovation, material science, and they're replicating that function with something that is actually okay for the environment. That's what I'm really, really enamored with that approach. Recycling's catching up. The new innovation's catching up. So I think we're on a really good path. It's just, we've made a lot of it. We don't have a good infrastructure to handle it. So it's going to be a big burden for us, but I think we're in a really good place.
One of your most cited studies looked at laundry pods.
Oh, yeah.
I know this got you in hot water in a few different ways.
Every day.
But specifically the polyvinyl alcohol in them. Now, these things were marketed as just dissolving. So what happens when it dissolves in the dishwasher or your washing machine?
We have this word solubility. It's kind of a weird chemistry term that I don't know as much about. But if you think about an empty cup that you just pour salt into, you can see the salt. But when you put water in it, you don't see the salt anymore. Or with sugar. But if you drink it, you taste it. So it's still in there. It's just not visible to the eye.
Okay.
And this polymer was designed to act in the same way. So when it interacts with water, it dissolves. And it releases the stuff from one end. It behaves really well. They set it up for that function, and it does that thing. The problem is we kind of confuse solubility with biodegradability, kind of. I don't know if I made that up, but it's a word now.
It tracks.
Yeah.
I don't see it anymore. It's not in the environment,
it's
right?
Kind of. So that's the mistake that we kind of made. And it was marketed as being biodegradable, plastic-free, eco-friendly, vegan, all these things. Not really true. I mean, there's a big focus on that. But for me, the focus should still be it's a fossil fuel derived material.
Yeah.
We're still going for oil to make it.
Yeah.
That sucks.
Yeah.
So that's problem one. And then problem two is it dissolves, but it's not biodegradable fully unless there's the most giant asterisk of all time is right next to biodegradable.
Right. Yeah. Is that illustrative of something about how we talk about like eco-friendly or biodegradable materials and products?
Yes. This is a field that really scares me because these words carry a big impact. Biodegradable, eco-friendly, natural, GMO-free. There are these big words that don't necessarily have a good definition. So what is biodegradable? That's the problem. That's where it starts.
Yeah.
Anything is biodegradable over millennia.
Right.
Anything.
Give enough time.
Right.
Yeah.
So what are the, like, under what circumstances, in what time, what conditions? How do we define the word? And because the word is a little bit loosey-goosey, then the companies can say, yeah, that's biodegradable.
Right.
I'll find a definition where this is biodegradable, and they slap it on there.
It's a marketing term.
Right.
Yeah.
But the problem is, if you look at the conditions that are needed, you have to have the right microbes. The microbes have to be trained to eat PVA. It has to be the same temperature, the same food availability, the same pH. None of those happen in the environment. We have big temperature changes from midday to evening.
Yeah.
So there's no way that all those conditions are the same. But if you set up those conditions in a lab and you put PVA in it, yeah, it's biodegradable, sure.
Totally.
But where in the environment does that ever happen?
Yeah,
it doesn't.
Okay.
So that's the biggest asterisk of all time. And it's a lot of greenwashing.
So when this stuff dissolves, becomes soluble,
Yeah.
and goes down the drain. It goes into wastewater systems, right?
It does.
And then ultimately those wastewater systems go where?
So wastewater in general is a really good thing, right? So the solids leave our house,
Yep.
and then it gets treated, so it doesn't really smell as much. There's not as many pathogens, things like that, and it reduces the volume. And then you have fertilizer, and that's normally a great thing.
Yeah.
And when we worked at a wastewater treatment plant, they said it smells like money. It didn't. It smelled awful. Awful.
Yeah.
But I get it because you're basically taking waste and profiting off of it. So
Yeah.
it's a good thing. So PVA would survive. We found that about 25% of it breaks down, 75% goes into mostly the solid waste.
Okay.
So then 3/4 of it's in the solid waste. And then what happens? I don't know. It's either land applied or it's burned or sent to a landfill.
Okay.
And in other plastics in that scenario, they don't have a great impact. And then with PVA, if I ask that question, there's a little evidence suggesting that it's bad, but it's just not studied. No one's looked into this, and that makes me nervous.
Okay. Laundry pods, etc. That's a source of microplastics ending up in the environment, both in the ocean, I assume, and also in landfill and like applied to agricultural fields. So that's having a similar stacking effect, right?
That's another weird area. It's not a microplastic.
It's not.
It's not. I don't know what it is.
Oh.
It's soluble, so it turns into particles. Does it remain like little PVA tidbits? Is it breaking down into something else? We don't know. But that's another reason why the industry goes after us, because they'll say, it's biodegradable under these conditions, and it's not a microplastic. We're good. Let's market it as being eco-friendly.
I had all these questions framed around that being a microplastic, but it's not.
It's scarier than that.
Yeah.
Right? A microplastic can get sequestered somewhere. If it's really small, maybe it's getting stuck in places a microplastic doesn't get stuck. Maybe instead of a microplastic ruining the soil when it gets land applied, maybe this gets sucked up by the plant.
Have you continued looking into this after that paper that I believe you published while you're at ASU, right?
Yeah, I published that at ASU during like peak COVID. We're still doing the work now. It's just hard to pay for. It's very expensive, but we work with a soil company that looks at how contaminants can affect not only soil health, but plant health, especially plants that we eat. So we do continue the work, and our research inspired a bio-based pod that has no plastic in it that's made from Maine kelp and Maine seaweed.
Dirigo Sea Farms, right?
Dirigo Sea Farm, yeah.
Okay. For those not in the know, Dirigo is on Maine's flag.
It's on Maine everything. Like
it's on
Dirigo plumbing, Dirigo washing machine. I mean, everything.
Yeah.
Yeah, but it's cool.
Let's talk about Maine. You
And Dirigo.
Yeah. You went from the desert to the Northeast. You now direct the Shaw Institute.
Yes.
Can you tell me what you're focused on there, what the Shaw Institute is, and how you ended up in Maine?
I graduated and I was eager for a job, and I wanted to stick around at ASU, but I think ASU was tired of me.
Oh yeah.
So I looked elsewhere. I found a cool position. Dr. Susan Shaw was hiring, and during the hiring process, she actually passed away. She had cancer.
Oh wow.
And so I kind of inherited this fixer-upper of an organization, and I'm not good at a lot of things, but I'm good at fixing things like that. So we got everything set up, and we just looked at what was big focuses in Maine, and that's ecosystem health, health of the water, making sure that aquaculture and the seafood is healthy. And I wanted to carry forward a lot of projects that I had done at ASU, and so we kind of hit the ground running, and it's been a big success. I actually lived in Montana for a long time, so people would say like, "Oh, you're from Arizona. Get ready for the winter." And I was like, this little amount of snow.
Yeah.
Like, give me a break.
It's a different kind of winter in Montana.
Yeah, it is a different. Although this winter in Maine was pretty significant. We got a decent amount of snow,
but it's temperate. I mean, like it's not dry, like blowing wind all the time.
No,
it's,
and we're down east. Down east is kind of like protected from everything else. It's not the north. I'm a little scared of northern Maine. I don't know what's up there, but
I've never been. I've literally never been.
There's probably a reason for that.
Yeah. So you've worked on marine ecosystems before. You did that before you came to ASU. You did it while you were here working on bioaccumulation in marine mammals. I assume that all translated pretty easily to Maine's coast. It's a very maritime state, right?
It is, yeah. And a big focus of ours is looking at PFAS chemicals as well. So we have a repository of marine mammal tissue there. We have sea lions on the West Coast, and those things are like Michael Phelps because there's sharks around. They're like in and out of the water, right? Seals don't have any predators in Maine. They just lay. They lay and they eat and they poop, and that's it. It's this great life. And they literally, one of their poses, a scientific description, is a banana pose because it's so happy and fat that its tail, it's like a tail to head, it's a banana shape.
Adorable.
Just laying. Yeah. So unfortunately, some pass away because there's just no predators. but we can look at their bodies as indicators of environmental health. They're top tier predators. Things move up the food chain. So we do a lot of work with marine mammals and PFAS, and that's been a big thing. PFAS in Maine is a big thing.
And PFAS, maybe a more well-known term is forever chemicals, right?
Yeah. People think about their nonstick pans. A lot of times PFAS was used there. So the chemical is a really good water repellent. It handles high heat, waterproof clothing, firefighting foams. It's something that serves a really important function, but it has these really bad effects.
Yeah.
But it's still something where if we were to say to a firefighter, do you want your PPE to have flame retardant? They're going to say, yeah, I don't want to catch on fire. So it's important to use it. It's just long-term. It's got a range of really bad health effects.
I just mentioned Maine is a very maritime place, culturally, economically, everything. So does the intersection of industry, ecology, and community ever make what you're doing there feel very personal? You have a front row seat to what pollution is doing to the coast. Does that make you resent the companies that are responsible for this type of thing?
I don't resent them. I always try to think about how progress is a giant table where I have Maine farmers or fishermen, and then I have sustainability experts. I have a health expert. I have someone that does economics, and I have someone that does material science. And I can say, all right, we've identified this thing as having a negative effect. So what do you need, big company, from this material? And they might say it has to be durable. It has to be heat resistant. Okay, how much does it cost to do that? And then economic person. And then I go to the material science person. Hey, is there anything in nature that we could use to replicate that?
Right.
And the material science person might say, you could synthesize, you could take something from seaweed, and that might replicate what's in plastic.
Yeah.
And then I would say, okay, well, the biggest obstacle here is funding. And then I would have that big company at the table because they have a big pocketbook. Wallet. How am I 80? Okay.
You're from Maine now.
Yeah. Oh, stop. Stop. Be nice. But essentially, that's the ecosystem that creates positive change. Because you want to make something that rivals the functionality and the price. And then once you do, all these companies could benefit from being more sustainable.
Yeah.
So I don't ever vilify them. I don't try to think about it negatively. But it is pretty special to talk to the lobstermen there who are traditionally not really eager to be into science, but say to them, hey, have you noticed any trends with the lobster? Yeah, they're not coming down as often and they're smaller. My catch is going down. Well, why do you think that is? The water's getting warmer. And it's kind of, it's like,
it's pretty good.
I don't have to argue with you. Like you know it. And you're probably more of an expert than me about the health of the ecosystem here. And that hits pretty close to home.
Yeah.
But it does make me feel better because I'm sorry to throw Arizona under the bus. I used to yell at people about water use out here and say, listen, we're running out of water. And then they're going and watering their lawn at noon.
Well, you should listen to our episode with Rhett Larson because he's adamant that we're not running out of water. We're running out of cheap water.
Right.
So...
Right. But we still have to be like, people, maybe don't fill your pool up and water your lawn at noon and maybe have a xeriscaped area.
We need to be more water conscious here for sure. Absolutely.
Yes.
But in terms of working with fishermen, as you noted, they see impact. They see climate impacts to their livelihood. I think the catch last year was down by like 18% or something because they're getting smaller, the water's getting warmer. And so, that's their way of life. Stuff like you're doing with trying to find sustainable solutions for these materials, kelp is a big one. That can replace, maybe not replace, but supplement their job. Right? It helps the economy in that way too.
Yeah. And you look at replacements as a way to move forward. So a lot of docks, they're buoyant, they're held above the water with styrofoam.
Yeah.
That sucks. Styrofoam is probably my least favorite material in the world.
It breaks up real easy.
Right.
Yeah.
So you can replace it with something else. Or buoys, styrofoam, replace it with something. And that's been done. They're using mushrooms out there, I think, to replicate buoys. But the thing that I hammer home to people that are interested in sustainability is an idea as something that you might put into place is maybe step 3 of 10. We're getting there.
Okay.
So what you would do, and I kind of joke about this, I basically say, if you want me to like flick your nose or kick you really hard in the shin, which one would you rather have? And you might say probably the nose flick, but in a perfect world, neither.
Yeah.
But I'll choose the nose flick. That's kind of science. So in that scenario, I might say, okay, let's replace styrofoam because it sucks. But you're going to put like a polycarbonate slab underneath it. And someone might go, well, it's plastic still. Yeah, it is, but it's not disintegrating in the water.
Yeah.
That is what we kind of have to accept. We have to understand that we're getting there, but it's going to take some steps to get there. And that actually happened with a lab in Maine. I have to tell this story. Sun chips are bomb. Okay.
Yeah, I like sun chips.
They put the garden salsa one on the plane. I'm not a fan of that one, but they're good.
Classic all the way for me.
Yeah, classic.
Yeah.
They came up with the idea for a compostable chip bag.
Oh, yeah.
And they tested the chip bag in Augusta, Maine, with the lab that I use for my PVA research. They came up with the idea, and it worked. And they were so proud of it, they paid for a Super Bowl ad, which is very expensive.
I do remember this.
And then it hit the shelves, and people opened the bag and found it to be too loud, so they stopped buying it. If I'm Sun Chips, I'm using twice the amount of plastic, and I'm saying on the label, throw this directly in the ocean. Why are we this way?
Yeah.
They thought it was too loud?
Well,
I know you sneak in the kitchen late at night, but deal with your issues, like whatever.
It's
too loud, and they stopped. Sun Chips wanted Lay's and all these other companies to use this technology.
Charlie, it fundamentally changes the experience of eating chips if it's too loud.
So much so that we're going to double down on using plastic.
Yeah.
That's a problem.
Our environment be damned. I want a quiet chip bag.
You want a quiet chip bag?
No, not that badly.
Right, exactly. But that's my point. And people will look at something and say, well, it's not perfect. I don't want it.
I wanted to ask about the mushroom buoy thing real quick.
Mycelium.
Okay. So one of the hallmarks in my mind of Maine is like every other house has like old buoys like hanging on their mailbox or their door or something.
Yeah.
Which I think is very quaint, and I love that. Would the mushroom ones just like deteriorate so quickly that you wouldn't be able to have fun decorations like that?
Yeah, so I can tell you right now that if you implement them, if you use the mushroom buoys, they're not going to last as long. And they're probably going to be more expensive.
Yeah.
But they'll fall apart into something that's not going to have a bad effect on the environment. But that's that, again, that intersection we get to where you have to say, I'm going to use it, take a little bit of a bath maybe financially, but I'm going to use it because I want this idea to get momentum. And I want other companies to say, no, I'm going to do that too. So I'm going to enter the race and make a cheaper one and all this stuff. Competition is what breeds innovation. And that I want that to happen. I don't want people to reject things at face value because they're not happy with it.
Sure. So, okay. Got to take a small digression. I grew up in Maine. I'm a Mainer.
Yeah.
You now live in Maine.
Yeah.
How do you like living in Maine?
I love Maine.
Okay.
I lived in Montana. I lived in California, Washington State, Arizona. Those former three states I mentioned, it's just a mix of those. Like I got there and I immediately I smelled the woods and it smelled like California. I saw the coast, it looked like Washington.
Yep.
And then the winter makes me think of Montana. It is so familiar to me. Now my wife, born and raised in Yuma, Arizona. So it was a risk. Like she was either going to die or she's going to love it.
Yeah.
And she had never had seasons before. So when the leaves changed, it broke her in a positive way. And she loves it. She does our outreach and education at Shaw Institute. And so that was the thing I was most worried about. I'll be fine.
Yeah.
But I don't think she could ever live somewhere else without seasons. I love Maine. I've never felt more community in my life.
Fun fact about Maine. It has more coastline than California.
Yeah.
You knew that?
Yeah, I heard the one I heard was if you were to stretch the coastline out in a straight line, it would go from Maine to California.
Oh, I've never heard that one before.
Yeah, I mean, they're just making stuff up.
It comes out to like 3,400 miles, so that about sounds
I believe
right.
it. There's so much stuff out there.
Well, it's just like all craggy and jaggy. And all the
it's not
inlets
pretty coast. I mean, it's angry rocks.
No, I mean, a Mainer's idea of a day at the beach is like freezing cold water and a bunch of like boulders.
Yeah, or tide pooling.
Yeah, or
tide pooling is awesome.
Absolutely rips.
And we actually have a 200-gallon touch tank now where I work. It's a nice little way to educate people and talk about the critters there. And they have some awesome hardy creatures there.
And you are currently part of a study looking at possible links between plastics and Alzheimer's disease. Can you tell me a little bit about that?
Yeah, I'm partnering with a researcher, Diego Mastroeni, I think. I've never said his last name, so I'm Diego. I'm sorry if I said it wrong. So he basically was one of those folks that said, I look at this disease and I study maybe biomarkers that suggest it's getting worse. And could plastic be something that makes it worse? And he said, like, could you create a method to work with brain tissue? And for me, that hits really, really close to home just because a lot of samples we get, whether it's placenta or GI tract, that person is still around.
Yeah.
But these are samples coming from people that aren't around anymore. And that it just hits really close. So we started working with him and started applying for federal funding. And we're hopeful that we get some to secure, this research partnership. But I never thought the research would go in this direction.
Well, it's currently funded by the Arizona Alzheimer's Consortium, I think.
Yeah, we got a grant with the Arizona Alzheimer's Consortium or Coalition.
Okay,
which is it's a wonderful step in the right direction. We applied for a proposal through the NIH. I would just love to be able to say there's no effect. We're not finding any plastics.
Right.
But it's also a weird time because there was a study that came out that said there's a spoon's worth of plastic in the brain, and it's under a little scrutiny at the moment.
I want to talk about the spoonful of plastic in the brain because you are a pretty visible science communicator. I wanted to specifically about the spoon and the plastic. Very sensationalist, right?
Yeah.
Got a lot of attention.
Yeah.
Mega clicks.
Right.
Awesome.
Right.
But how do you then balance getting attention, but getting it responsibly? Because there's a middle ground there where you can be credible and not talk about a whole spoon's worth of plastic in your brain, which turned out to be not necessarily accurate.
Yeah, this is a really important concept, and it's a little bit sensitive. With any type of new research, there's going to be something where you maybe walk it back a little bit.
Yeah.
Put yourself in my shoes. I applied for a conference with my PVA research.
Sure.
Just an update on our work.
Mm-hmm.
When you put in a session or an abstract, there's a chance for the media to look at them, and the media might call you and say, "Hey, I want to do a story about what you're working on," which happened to me.
Mm-hmm.
And they said, "Does this material, if it's in your body, cause cancer?" I have two routes I can go. Route one is having something foreign in your body can cause inflammation.
Yeah.
Inflammation is a precursor to cancer.
Yeah.
Therefore, it could cause cancer. Option two is I don't have any evidence right now to suggest that. I went with option two, and she said, I'm going to run a different story then on something else. That happens a lot in science, and it's unfortunate. With the plastic in the brain study, so that instrument that guy used, I have that instrument.
Mm-hmm.
It's one of the most sensitive you can use. It basically turns whatever you put in it into a gas, and it reads the gases. It's called a mass spec.
Okay, yeah.
Now, you're made out of carbon, and I'm made out of carbon. Plastic's made out of carbon.
Yeah.
The instrument, because it's so early in its usage, can accidentally mistake fat for plastic. And the technology hasn't caught up to the point that the companies can integrate it into their software to be able to say, no, this peak or this signal, that didn't come from fat. That came from the plastic. We're not there yet.
Yeah.
So
there's a lot of fat in your brain.
It's 60% fat.
Yeah.
So if you're not careful, when you look at the data at face value, it's going to say there is a ton of plastic in your brain, polyethylene.
Yeah.
This instrument, the best comparison I heard for it, it's like going to a full symphony and trying to figure out which instrument is playing B minor. It's that sensitive. It's really hard to find something within the cacophony. Was that the word?
That's a good word.
Yeah. Cacophony of stuff that it's able to sort of see. And there's a lot of things happening in our body, and it's able to see all of them. And you're trying to pick out one little thing.
You took me in a different direction than I thought, because you're talking about responsibly communicating.
Yes.
Right?
Yes.
Without sensationalism.
Yes.
Pulling back to just looking at science communication in general, do you think that scientists have a greater responsibility to just communicate, period, especially now?
I think there is a massive lack of demand for that.
Okay.
There's no incentive to be a good science communicator.
Really?
No.
Okay.
You're supposed to present at a conference and teach. That's it. Mm-hmm. I try to communicate now with students that as a scientist, I can be in this chair with you. Mm-hmm. This is good for your career.
Yeah.
It makes you a better communicator. It makes you be able to promote your messaging, right?
I thought you were talking about my career.
Well, both of our careers. Yeah, I mean, this is good. This is good stuff. Yeah. I'll say some controversial stuff. You'll get a headline.
Excellent.
But this is really a positive thing. You can get paid to give lectures. I mean, it's a good thing, but it needs to be incentivized. Mm-hmm. And there's just none of it right now. But I think it's so amazing if you can talk to a 10-year-old that comes by and asks you about your work. If you can communicate what you do, it's a big win.
Yeah.
And that just makes you so much more important to the field of science.
So the scale of the plastic pollution problem, it's large. Mm-hmm. Is there a different way you think people could think about this problem without feeling just like totally daunted and overwhelmed?
Yeah, I think what the message I always try to convey when I end a talk is it's complicated. Mm-hmm. And if someone comes up to me and says after I talk about something, they say, if we just, I always say, it's not that simple. And that comes from experience. That comes from me giving a talk and someone saying, if we just ban straws, why do we need them? And before I got a single word out, someone raised their hand and said, I had a stroke, I need straws. And it's like, that's why. You can replace it with something else, that's fine. But if you don't want to use it, then don't. But we can't. It took 80 years to get into this mess. We're not going to get out easy. We're not going to get out easily, and we're not going to get out with if we just. It's really difficult to do that. And a lot of people come up with these regimens for how I avoid it. Mm-hmm. I do this. I get my milk delivered in a glass jug and all this. First of all, that's now inaccessible to any middle or lower income family. It's just for rich people. Like, cool that you do that. But then there's always devil's advocate. You always have to think on the other side. Okay, you eliminate plastic. What do you use instead? Well, glass. Okay, glass is heavier, uses a lot of water to clean. Mm-hmm. That's a problem. Well, okay, what about aluminum? Well, aluminum can be expensive too. And it's also difficult to recycle. It's expensive to recycle.
Yeah.
Well, it's always, there's a lot of things that come up. I mean, you're surrounded by it.
Yeah.
You just have to forgive yourself a little bit. And if you can find ways to avoid something, like if I bring a metal straw with me, big win. Awesome. Mm-hmm. Tell your family about it. But don't go as far as to, try to just ban it all because you think your experience is applicable to everybody else. I think that's the big challenge. I try to tell people it's complicated, and then I end on things I'm excited about when it comes to plastic.
So looking ahead 10 years, we talked about how we don't really know what's going on with polyvinyl alcohol in the environment. Is there anything else you hope that we understand better about just pollution and ecosystem and human health 10 years from now?
I hope that we understand that we can pinpoint to a certain contaminant and be able to demonstrate a negative effect from that specific thing. Mm-hmm. I hope we have a little bit more progress in my field, but I hope that we have that ability. And honestly, that ability is going to come from physicians and researchers working together. Okay. Because I can only assume. Yeah. Right? If I find plastic in a brain tissue sample, I would sort of think, yeah, that shouldn't be there. But I don't know what it's going to do.
Right.
But if I work with Diego, then Diego can say with his experience, yeah, these are the effects of having something like that in the brain. That's really powerful. And I do hope there is more unity between science, between doctors, like physicians and researchers. Mm-hmm. And I hope we improve our communication. I'm trying, but it's a big battle. And I do, a lot happens in Maine, right? Maine has a big focus on eating whole foods and having it be natural. So then they'll say, no, this is natural. It's good. And then I'll say, what do you treat your well for? And they'll go, arsenic. I'll say, oh, that's natural. Mm-hmm. So is a bear and a shark. Formaldehyde we produce. So it's a term that I hope we clear up a little bit. Yeah. So that it's not so you can put it on there, but it's like, is that really descriptive?
So, okay. We talked earlier about how these are marketing terms, right? Do you think there's a need for regulation around some of these terms? Because, you could just say like, oh, it's all natural, and there's no legal definition of that. Yes. As far as I know.
What's a microplastic?
Yeah, okay.
What's a nanoplastic?
Okay.
What's non-GMO? All these things have these words, they slap it on a label and they say it's healthy and organic. All these terms carry weight with them. Right. And there's a lack of transparency when it comes to our understanding of it, right? So we say, oh, this is good because it's non-GMO, and then we eat seedless watermelon.
Right.
Or we don't look at our pug and think that used to be a wolf.
Do you have a pug?
No.
Oh, okay.
They're great dogs.
They're cute. I wouldn't buy one though.
But that used to be a wolf. Yeah. And then we modified it genetically.
Yeah.
And we look at how corn used to be like this, right? Tiny little, like 10 kernels, and now it's huge.
Yeah.
So genetically modifying something isn't that bad.
Right.
So we're getting there where science communicators are getting better at making this more transparent, like defining these terms. Define organic. That's a touchy one in Maine. Because organic, they'll say all natural, no pesticides. There are pesticides in organic food.
Yeah.
Like that you can have natural pesticides, right? But again, natural is arsenic. It's not healthy. Doesn't mean it's good for you. But we have to break those terms down a little bit and try to understand that. And I think thanks to podcasts like yours, it gives the scientists the microphone, and those that are good communicators can actually explain what something is. And I didn't necessarily know this until my friend James sort of said, let me draw the chemical structure of a pesticide that's not natural. And he drew it. And then he said, let me draw one for one that is natural. It's slightly different, but not much.
Yeah.
So it was really powerful in that moment. And if I can get folks like that a microphone, then we start to understand things. But to your question, yes, it needs much better regulation. We have to agree on things.
Yeah.
I remember I published a paper on wastewater treatment plants and microplastics. I just wanted to know what they were finding. I looked at all the different terms for microplastics: sphere, foam, ellipse, fragment, glitter, fiber. Like what the hell is a sphere relative to like a nerve? Like what's a fragment? What's an ellipse? The hell does that mean?
Yeah.
So it's like if we can't even agree on terms or how big
the scientific community can't.
Right.
So, yeah.
We have to come to a consensus, and we have to come up with something that's not going to be perfect. Someone might disagree. It's like making a logo. Someone's always going to say like, I don't like it. But if it's good, if it conveys the thing well, let's go with it.
Right.
And yeah, science needs to do a better job of that.
We've covered a lot today.
Yeah.
But is there anything that you would recommend people to read, watch, listen to that might help them learn more about some of the topics we talked about today?
Your podcast.
Oh, thank you.
I think this represents something extremely powerful.
Thank you.
Because now I can talk to people that do podcasts and discuss how you put this together. It's not easy, right? Putting scientists in a chair, asking them questions that allow them to kind of open up a little bit and reduce the science jargon. That's not easy, but it's a necessary thing to happen. I love that idea. And there's also a podcast called Science Versus.
Oh, I love Science Versus.
Science Versus is really good.
Yeah.
Because they'll go through some really important topics. And at the end, they're proud of their citations.
Yeah.
So if people that don't know, citation just means I found something that's fact and evidence-based, and that's what I use to come up with this information. We need citations on everything these days. Whenever someone says something and they make a claim about something, especially politically, there should be a source that's checked. But I love Science Versus because they are transparent and they put it right out there. So if you're interested, you can go right to that source. And I think that's such a great system to have in place, so that people don't have to say, well, where did you get this information from?
Charlie, thank you for coming on the show.
Thanks for having me. It's great to be back.
It was so nice to talk to you.
You have to visit me now. Brunswick's not that far away.
I'll be in Maine in July. I'll make the trip up to Blue Hill and take my kiddo to see your touch tank.
Yeah, I think by then our newest species we're acquiring is a seahorse, because Maine has seahorses.
They do have seahorses.
Which is crazy to think about. But they're this hardy, resilient seahorse with an accent that sticks around through the cold winter months. So it's, I'll come through. You have to hold a sea cucumber and a sea star. And we have a crab named Hannibal. You'll have to hold him too.
Okay, cool.
Yeah, he earned his title, but I'll protect you.
I can't wait to meet Hannibal.
Yeah, good.
All right. Thanks so much, Charlie.
Thanks for having me.
Thanks for tuning in. If you enjoyed the show, please leave us a 5-star review on the podcast app of your choice. If you found us on YouTube, we'd appreciate a like and a subscribe. Lab Coat Optional is brought to you by the talented people at the Knowledge Enterprise Strategic Marketing and Communications team. Knowledge Enterprise is led by Executive Vice President Sally C. Morton. Remember, lab coats are optional on this show. We want to keep our researchers safe in the lab, so wear your PPE. Until next time, stay curious.